In this video, we're going to practice finding some more cutoff values for some different setups here. So we're still going to be working with women's heights. And we're going to first start by trying to find the value that cuts off the 25th percentile. So one thing I want to actually make sure we define first is what a percentile actually is. So for example, my son is at the 97th percentile for height for kids his age. So what this means is that he is taller than 97% of kids his age. So when I think about percentile, if I have the kth percentile, what that means is that k% of the data is below it. So if I'm trying to find the 25th percentile, that means I'm going to have 25% of my data below it. Let's make sense of this in a picture. So I'm working with women's heights, which I know has a mean of 65 inches. And 65 actually corresponds to a pretty important percentile. It would be the 50th percentile, since 50% of the data is below it. So what that means for me is then is the 25th percentile is going to have to be somewhere smaller than that 65, since 65 is our 50th percentile. So I'm going to want this shaded area to be 25%, or in decimal form is 0.25, and our goal is to find this height along the bottom. What I can also tell from my picture is that my z is going to be negative again because I fell below the mean. So following these steps, we've done the first two, and we're now going at step 3, figuring out how much area is to the left of that value. Again, we're looking left because our table looks left. So how much is to the left of my question mark? This 0.25. So I'm going to go looking in the table for 0.25. But remember, this 0.25 is actually a number on the inside of my table. So again, I'm going to give it 4 decimal places. I'm going to add those zeros to it so I know where to look. Again, I can tell from my picture my z should be negative, so I'm going to be on my negative page. Just as before, I'm going to go down this first column looking for my jump of 0.25. So I see 0.15, 0.18, 0.21, 0.24, 0.27. So 0.25 is somewhere between those two values. Working over in those 2 rows, I'm not finding things quite as close as I did last time. I see this 0.2514 and this 0.2483. If you were to pick either of those, you're probably going to be fine. I'm going to pick the 0.2514 because it's a tiny bit closer to the 0.2500. But again, remember, that's not my answer for my z. Now that I know where I'm looking, I've got to look at what row, negative 0.6, and what column, that 0.07, correspond to this value that I found. So putting those together, I'm going to get a z of negative 0.67. Or I'm going to have to go 0.67 standard deviations below the mean to get that 25th percentile. At this point, I'm just going to be plugging in things into my formula I have here, because now I have my z and I already know my sigma and my mu. So now doing our math, our z is negative 0.67, our standard deviation was at 2.75 inches, and my mean was 65. Doing the math here, we're going to get 63 0.16, this is a height, so those are inches. So then what this value actually means for us is that 25% of women are shorter than are 63.16 inches. And that's it. So these always feel like a little bit less work, and so sometimes you feel like you forgot to do something. But that's it. Once you can interpret it, you can also then think to see if that answer makes sense. Okay, let's try a different problem. What height cuts off the top 25% of women's heights? Well, how is that different than what we were asked for in part A? Well, this time it specifically says the top 25%. So this would be like our tallest 25% of women. Well, so half or 50% of women are taller than 65 inches. So to be that top 25%, I'm going to be shifted over this way. So this time I want this shaded area to be 25%, or in decimal form, the 0.25. And our goal is to find that height along the bottom. So this time I know my answer better be bigger than 65 inches when I'm done, or I've done something wrong. Our next process is to go to the table, but what we need to know is what number to go with to that table. This is where step 3 is important. How much area is to the left of that value? Well, here's my value. How much is to the left of it? Well, I don't already have that labeled. But what I know is if there's 25% to the right of it, that means I know that 75%, or 0.75, is going to be to the left of that value. So that means we're actually going to go to the table looking for the 0.7500 because my table always reads left. Right, I know this time my z should be positive as well. So we're going to go to the positive side of the z table. Going down that first column as well, I'm looking for my jump of a 0.75. So that's between my 0.7257 and 0.758. Looking for the closest thing we got. Again, I kind of arrive at two numbers that aren't extremely close. The 0.7486 though is a tiny bit closer to our 0.7500. Now, remember, I'm going to look at what row and what column is that value in our table. So our row is the positive 0.6 row, and our column is the 0.07. So putting that together, we're going to get a z of positive 0.67. Notice how our z-scores for part A and part B compared. Is that a coincidence? No. Here we're finding the bottom 25%. Here we're finding the top 25%. What that means is we're going to go out the same distance from the mean, just in the opposite direction. So here we're going 0.67 standard deviations below the mean, and here we're going to go 0.67 standard deviations above the mean. And this works out because my graph is symmetric about that 65. Now actually doing the equation, this time again our z is just positive 0.67, but the standard deviation is still 2.75 and the mean is still 65. This time instead of getting below the mean, we're going to get above the mean, and we get 66.84 inches. So how would I interpret this? Well, the question specifically asked for the 25%, so I'm going to interpret in terms of the 25%. So I can say that 25% of women This time that's shaded to the right, so they are taller than this 66.84 inches tall. All right, let's try another problem that's a little bit different. We want to find what values separate the middle 75% of women's heights. So let's start with the picture. We still have that mean of 65. This time I want a middle 75%, or 0.75 in decimal form. And I'm trying to find two values along the bottom. So I'm going to call this question mark A and question mark B. Just to help myself out, I'm actually going to figure out what values go here and here. Because if I have 75% in the middle, that means I have 25% left that can go on my picture. But I have two different spots to put it in. So I'm going to take that 25% and divide it by 2, which is going to give me 12.5%, or 0.125 in decimal form for each of those pieces. So my entire picture adds up to 100%. So I really have two different values to find. Let's first focus on finding question mark A. So our first question then is, how much is to the left of this value? Well, that's our 0.125 that we just talked through. So that's going to be the number I'm going to go looking for in my table, is 0.1250. For question mark A, I know that it's going to be below the mean, so my z-score should be negative. So going to my negative page, again, I'm going to go down that first column looking for my jump of 0.125, which happens somewhere between 0.115 and 0.1357. Working over to find the closest thing we got. We find this 0.1251. Now, what does that actually give me for my z-score? Well, the row I'm in is negative 1.1, and my column I'm in is the 5. So putting those together, we're going to get a negative 1.15 for my z-score. So then I can do the math for this value. My z is negative 1.15. My standard deviation is still 2.75. My mean is still 65 inches. And so I get 61.84 inches. So now I have one of the values done. But now I need to talk about question mark B. There are two different ways to approach this. I'm going to approach it using our picture here first. So what we got to figure out is what value we're going to go to the table looking for. So looking at this question mark, I have to figure out how much is to the left of that question mark. Well, it's the 0.75 and that 0.125. So I've got to add those two values together, because both of those pieces are to the left of my mean, of my value. So that's the number we're going to go looking for in the table. This time we know our z should be positive since we are above the mean. So we're looking for 0.8750. Looking for our jump is between our 0.86 and 0.88. Closest thing we find is this 0.8749. And what does that correspond to for a z-score? Well, my row is positive 1.1 and my column is the 0.05. So putting those together, we're going to get a positive 1.15. At this point, you might actually already see the other way to have found that number. Notice here when I'm looking for that middle percentage, my z's are going to be the exact same value. One's just negative and one's positive. But it is important to make sure you draw the picture so that you knew that we're looking for this 0.125 when we went to the table here. That might be hard to see initially when you see that 75% of where we got that 0.125. So drawing the picture is still very helpful in figuring that part out. Now doing the math for our value for question mark B, we're just having our positive 1.15, same standard deviation, same mean. Of course, a different answer since we're going to be above the mean this time. So then finally, I can say the middle 75% of women are between 61.84 inches, roughly 5'2", and 68.16 inches, or roughly 5'8". Alright, finally, just to understand the idea of percentiles a bit better, we're going to figure out what percentiles were each of these values above. So this 61.84 inches, what percentile does that correspond to? Well, recall a percentile has k% of the data below it. So what percent of our data is below 61.84 inches? That was this value we were finding on our chart. So 12.5% is actually what's below it. So this value would actually be the 12.5 percentile, because we have that 12.5% below it. So then our 68.16 inches, how much was below it? The 75% plus that 12.5%. Notice that math we had to do here. So this actually gives us our answer. This is actually the 87.5 percentile, because there's 87.5% below it. Alright, so in the next video, it's going to be your chance to practice some of this on your own, and then again to use the video to check your work.